We just had a thorough discussion about abstract classes and interfaces, and indeed, they are, in fact, applications of the inheritance in general. And the final piece of the puzzle for inheritance, which is a very big topic, will be about generics in Java. And the way I would like to approach this would be to think about really what's really the rationale for having generics rather than otherwise. And I'm gonna actually talk about syntax for generics, and also most importantly, you want to understand why we're using generics. It's a very important rationale about the design over here that's gonna be covered in this part. All right, so let's look at the learning outcomes. I'm hoping that you will learn about a general collection. So this is one example. So we simply got an array where every element in the array statically will be an object. So that makes the storage very, very accommodating, meaning that any object whose static type is actually a descendant of objects can be stored into the array, right? That's still following our principle for substitution, and also the polymorphic method parameter subjects. And what about retrieval? So that will be something that we'll criticize about a general book. So there's no silver bullet, really. If the storage is really easy, in that case, retrieval, you might suffer. Okay, that's something we'll speak about in detail in the actual lecture. And we want to compare and contrast a generic collection. In this case, for example, let's say we got an array, and now we say that every member or every element in the array statically will be a certain type, and the type itself is actually parameterized. It has become a parameter at a class level. Whenever you want to declare some class, you want to actually supply what this E is as well. That's maybe a very new idea to every one of you, most of you. In that case, I'm going to speak about also in detail later. And we'll talk about in this solution over here, it will be more balanced between storage versus retrieval. Storage may not be as accommodating as the storage for the case of general collection. However, it's much more controlled in the case of a retrieval. So I will actually encourage you to really adopt the generic solution after this entire lecture. Okay, that's something we'll see. And we're still going to reinforce the idea about polymorphism and specifically typecasting. So we're going to reinforce. Remember when we actually spoke about the abstract classes and interfaces, we actually revisited polymorphism and dynamic binding. But in this case, for generics, we're going to revisit typecasting and also instance of checks at the runtime. Let's now take a look at one motivating example. It's simple enough, again, to really illustrate the idea, but it's also detailed enough so you can understand every aspect that should be you should understand about the issue of general versus generic. Let's now take a look at one example class. Let's say it's a book class. Okay, and in the book class, we actually got two attributes. We got two arrays. So one is called the names, the other one is called the records, and we got two arrays. The name is simply an array of strings, and the records is more like a general book, as I just mentioned before in the learning outcomes. So it's simply an array of objects. Okay, and let me visualize that right away just to give you some idea, and then I'll leave the implementation part for general and generic book later, both as exercises for you later. Let's take a look. And for now, you don't have to worry about this fragment just yet. Okay, you can focus more on this part of the notes with me. Okay. So let's say we got two arrays. We got names and also we got records. Two array names and also records. So the assumption is they are equally long. The length of the two arrays is simply the same. That's something we assume. And then, so what does it really mean to have these two arrays? The idea will be the two elements stored at the same index between the two arrays is going to make one pair of entry. Okay, for example, if you're storing, let's say, a birthday book, in that case, if this is a person's name, for example, Alan, in that case, at a corresponding position in the records array, it will be Alan's birthday. And for example, let's say this is the record for the name for Jim. In the corresponding position, it will be Jim's birthday. So depending on what record you're storing, it could be storing telephone number, it can be storing birthday, and etc. Okay. And what about the methods we want to support? Let's now just take a look. So here we have actually two methods, one mutator and one accessor. Okay, so in the mutator add, we want to add a valid entry into the book, right? Into the book over here. And let's now take one example here. Let's say if I have, I have a particular name and also a particular record over here. And now just remember, let me remind you right away, right? So we know that if the parameter type is declared as objects, right? So that means because call by value, we know that record over here is going to be assigned to some argument value. So we know that the argument objects static type must be a descendant of the static type for the parameter. Must be a descendant of objects. That's something that should be very natural to you right away. All right. So we're saying that any argument object static type must be a descendant of the objects, which is over here. All right. That's the polymorphic method parameter that we spoke about before. Okay. Let's say now we got name and also we got record, right? What's going to happen is, let's say for the very first record, we're going to store them in index 0 in both array. So this will be the name and this will be the record, right? Let's just take one more example here. Let's say if we got another name and also record pair. In that case, we're going to store index 1. So the name over here and also record over here. So you can see at index 0, these two items in the two arrays will make one valid entry for this particular name. And also at index 1, so these two items will also make a valid entry as well, right? That's kind of the visual idea. But you will definitely have to implement this yourself to really practice, all right? So that's the mutator. Let's now take a look at the accessor. How do we get given a particular name, assuming that the name is actually valid, right? You can also try to implement yourself by saying if the name doesn't exist in the names array, in that case you might throw certain exception. I'll leave that to you. Okay. Let's say, for example, if I have, let's say, the name over here, so what will be the corresponding record? For example, the name exists over here, so that means the corresponding index in the other array, so this one over here should be returned as the record, right? Similarly, if I give another name over here which also exists, in that case, given this name over here, so the corresponding record should be the corresponding index in the other array. And you can see the type over here is actually objects, right? And we also learned about polymorphic return type in last week's lecture. Let me also annotate very quickly for you. Over here you can see this is objects, right? So this means return values dynamic type must be a descendant of objects. But we know very well that object is the common parent class for every class. So only requiring that the return value dynamic type should be a descendant of objects. That means you can return anything, because anything has its descendant. Any class in Java is simply the descending class of objects, just by definition. But just keep that in mind. So we'll speak more about storage versus. We'll speak about storage versus retrieval a little bit later. But let me just highlight one more thing, and then we'll continue with the example. Right? It's really important for you to understand the setup for this motivating example. So this type over here is concerned with the storage, whereas this part over here, the return type, this one is concerned with retrieval. Right? Retrieval meaning that you want to retrieve something from the book. All right, let's now consider some fragment of code, and then I would like to give you some exercise. Okay, let's now move back to the slides. Right? Basically, I just want to go over line by line together with you this fragment of code, and then we'll let you pause the video and do the exercise. All right, we spoke about this fragment over here already. Let's now consider the following test code for this book class over here. And in order to really answer the questions below, you don't really need to know exactly how the methods are implemented for both the add and also get. Right? That's something I'll leave as an exercise for you, which I'll assign to you at the end of the lecture. Let's say the first line, we declare two variables here, and the dates class over here actually came from the Java library. Let me show to you very quickly that class. Okay. So if you simply launch your search, for example, in Google, over here. Okay, so you can just search for Java API the dates class, and then you simply go there. So that's a date class that we're using. It's a standard Java library. Okay, specifically, I want you to search for a method called getDate. Okay, it's being depreciated, but that's okay. You know, just for our illustration, we'll still use it. It can still be called. Okay, let's say this getDate. If you click on that, you will see some summary, right? I assume some basic knowledge about how to navigate between Java API from your first year. If you got any doubts, you can definitely reach out to me. Okay, and the return value given a particular date, we simply want to know about which day of the week is represented by this date. For example, the return value 0 means, for example, if you return some birthday, let's say October 15 of somebody, so you want to know which day of the week was that person born, right? It can be 0 for Sunday, and 1 for Monday, 2 for Tuesday, and etc. All right, that's the getDate method. I'll let you explore further if you're interested. But at least we assume there such method exists. All right, so that's the first line, and then we also got a string that for storing a telephone number, right? So the first line is only to declare 2 variables. Okay, line number 2, we are declaring an instance of book, and we just call it B, right? You can see the book is actually here, and also the Boolean, whether or not a particular birthday, which we're gonna see, is a Wednesday, meaning that the value will be 3, the integer value. Okay, line number 3, we actually try to create a new instance of book, right? Just a new book, and then assign its address to B. So far, very straightforward. And we also got phone number. Phone number is simply this particular phone number, okay? Just a string. And let's say line number 5, it will be, we want to add the following entry into the book. So this will be the name of the person, Suyang, and also some phone number, all right? And then we got birthday is assigned to a new date, right? And that was simply 1975, April 10th, right? And then we actually say b.add. We want to add a second entry into the book. And we say the name for the person will be Yuna, and also their corresponding record will be just the birthday that we have just created, right? So far we have added 2 records into the book. And finally, line number 8, we want to say b.get Yuna over here. Because remember, we just added for Yuna their birthday over here. So we want to get the dates that we have just added in over here, and we want to see which day it is. So we say 4. So that means we want to know whether or not their birthday is actually on a Thursday. That's basically what we want to do. Okay, so the question is, which line or lines actually got a type error? That's the question. All right, you can pause the video and think about it and sketch your answer on a piece of paper to tell me which line or lines, and then give the detailed reason about whether or not you think there should be a type error. All right, pause the video and think about it.